Okay, here's the soma, this entire cell body of the neuron, containing all these organelles packed in it. The nucleus is this structure right here, and the nucleus has nuclear pores. You can see these holes in the nuclear membrane. They're called nuclear pores. The nucleus contains the genetic material. That's its function. And the nuclear pores is for ingress and egress of material. Inside the nucleus are these darker staining areas called nucleoli or nucleoli, and they're numbered. You can see that number 2 right there. That number 2 is on a nucleolus. And by the way, you can see a number 1 right there through the nuclear membrane. Can you see that? Mm-hmm. That number 1 is the nucleus. So you have number 1 is the nucleus, number 2 is nucleolus or nucleoli. The neuroplasm is just the cytoplasm of the neuron. It's just a fancy word for cytoplasm. So just this liquid part of the soma is the neuroplasm. Now, Niesel bodies, again, is just a fancy name for an organelle you already know called rough ER. So this number 8 right here, 8 is actually naming all the ER. But you need to know the difference between these endoplasmic reticula. These are Niesel bodies or rough ER, and these are smooth ER over here. So you have to know the difference between the ERs. Mitochondria are these number 7s right here, and some are cut like that one, and some are uncut like that one. These are mitochondria. In addition, there are some mitochondria in the axon. You can see a mitochondria right there in the axon. So they're not only in the soma. The Golgi apparatus is this green structure. It has a number 6 right there. So 6 is the Golgi apparatus on this model. And the Golgi apparatus pinches off little vesicles like you see here and then you see here. That's number 5, and that's the Golgi vesicles. And the Golgi modifies and packages proteins, and the Golgi vesicles do vesicular transport. They take the product someplace. Lysosomes. Number 4 are lysosomes. They do intracellular digestion. They can digest like an old worn out mitochondria, say this mitochondria here was old and worn out, senescent they call it. This lysosome could digest it. It could also digest any viruses or bacteria that entered the cell. Dendrites. This is probably the most commonly missed structure on this model. These appendages sticking off the soma, here, 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 are dendrites. And actually the dendrite is numbered number 12 right there. The reason, it doesn't seem hard, but the reason it's most commonly missed is because these guys are not dendrites. These guys right here are the ends of other axons coming into this neuron. And they actually have names, telodendrian and synaptic terminal, and I'll come back to that in a second. But this telodendrian and that synaptic terminal is not a dendrite. That's the dendrite. This telodendrian and synaptic terminal is not a dendrite. That's the dendrite. So make sure you get clear on the dendrite versus telodendria and synaptic terminal of another axon. That's the most commonly missed one. This is the axon of this neuron, and the very first part of the axon is dilated or large, and that's called the axon hillock. It's probably that number 10 right there. Although you have to be careful because on the key, number 10 might say neurofibril. Although I bet you number 9 says neurofibril because it looks more like it. So when you look at the key, just this dilated part of the axon is the axon hillock. It contains the trigger zone for this neuron. That's the function of the axon hillock. Then this is the axon. It became thin again, where you can see the axon right here, nice and easy with number 11. And then the axon's been cut, so you can see the axoplasm. The axoplasm is just the cytoplasm of the axon. So number 11 would be axon, and this would be axoplasm. The axolemma is the cell membrane of the axon. This blue edge. This blue edge is the axolemma. And what we discovered in lab today was on the key, this number 16 is actually axolemma. But be careful, because it's also a great place to label the node of Ranvier. So I'll come back to the node of Ranvier in a second, but the blue edge is the axolemma. Number 16 in your key is saying axolemma, and that's true, but it's also a good spot to name or label the node of Ranvier. Okay, this is a Schwann cell. Oops, do it like this. This one goes over here. So you see two Schwann cells here. See a Schwann cell here and a Schwann cell here. So this is a Schwann cell. Its function is to wrap around the axon and myelinate it. And when you wrap around the axon and myelinate it, you can see some structures that come out of that. You can see most of the cytoplasm is pushed to the periphery, and you can see the nucleus is pushed to the periphery. That number 17 is the nucleus of the Schwann cell. The myelin sheath are these layers and layers and layers of Schwann cell plasma membrane, right here and right here, that insulates the axon. This stepwise process right here, the model is showing you stepwise the layers and layers of myelin. So this is all the myelin sheath. Number 19 is the myelin sheath. Now there are some residual cytoplasm left in the myelin sheath. What number is that right there? Can you see it?
18.
18. You can see this cleft right here. It actually has a black line drawn to show you the cleft. That's called the Schmidt-Lantermann cleft. That's the Schmidt-Lantermann cleft. All it is this residual cytoplasm left in the myelin sheath. So these things are just residual cytoplasmic. They're called myelin incisors sometimes, or the Schmidt-Lantermann cleft. Between two Schwann cells is this node of Ranvier. When this axon fires, when any insulated axon fires, it only depolarizes at the nodes of Ranvier. So when the depolarization jumps from node to node to node, that's called saltatory conduction. So that's called a saltation point. The node of Ranvier is called a saltation point. And then lastly, what I have here is I have the ends of other axons hitting this neuron. And I have this thin telodendria and this dilated synaptic terminal. Thin telodendria, dilated synaptic terminal. Thin telodendria, dilated synaptic terminal. I want you to notice something. This synapse is an axodendritic synapse. It's this axon plus that dendrite, axodendritic synapse. This synapse right here is an axosomatic synapse. This axon and the soma. So axosomatic synapse. Another axodendritic synapse. Another axodendritic synapse. But over here I can see the third kind of synapse, and this is an axonic synapse because this axon and this axon hillock of this neuron. Axonic synapse. That's it.